بسم الله والصلاة والسلام على رسول الله. اللهم علمنا ما ينفعنا وانفعنا بما علمتنا وزدنا علما. So today, inshallah, we'll talk about cloud computing forensics. We know that over the last decades, organizations have moved significant portion of their data and services to the cloud. This change has changed also the way that digital investigators conducted their investigations. So today's employees store their data in OneDrive, collaborating using Google Drive, and also host services sometimes in Amazon Web Service, and access these applications through cloud to platform. This shift has changed the way that digital forensics are conducted, as in traditional forensics, investigators often knew where the evidence was located. It's usually in hard disk drive, in mobile phones, etc. But in a cloud environment, evidence can be distributed across multiple devices, locations, and even different countries. And we will see this in details in today's lecture. So the cloud has introduced ways of managing data that did not exist a few years ago, in the sense that it facilitates saving and accessing data and application over the internet rather than local systems. Cloud investigations have unique challenges, and that's due several reasons. We will see it in details today. For instance, the cloud services can be accessed from different devices as long as the device is connected to the internet. Also, they can be accessed from different platforms, such as either web platform or application. So, as you can access, let's say, OneDrive either from OneDrive application, or you can access it from the web services, which is through the, for example, Google Chrome, from any web browser. So what is cloud computing? Cloud computing is a service which offers customers to work over the internet. And this states that cloud computing means storing and accessing the data and programs over the internet rather than computer hard disk drive. And there are a lot of advantages why we are moving towards cloud computing. What we can store in cloud computing, we can store a lot of data. This includes videos, audios, documents, and many other things. And the good thing is that user can access these files anytime from everywhere. Before we explain the cloud computing further, we will discuss the industrial revolution. So the following slides, just like a general information about how the industry is moving from one decade to another decade. So in the 19th centuries, which is the first industry one, and the machines has been introduced to power the water system. Moving to industry 2, and there is a new introduction where the machine introduces, where the machine were utilized in the electricity and the assembly lines, etc. When we move to the industry 3, industry 3 introduces computers and automation at the same time. In industry 4, the IoT has been introduced, where connected machine systems and data using technologies such as IoT, cloud computing, and AI. But in industry 5, here, it builds on industry 4. This industry 5 builds on industry 4, where the collaboration, focus on the collaboration between a human being as well as an intelligent technology rather than replacing a human. So here where the AI centered and the collaboration between the human and the technologies. So industry 4 in generic, often called the smart industry, because everything becomes connected and data driven. Machine user generate data through an IoT devices, cloud computing store and process data, big data analytics, extract insights, As you can see here, big data, it extracts insight from this large data. From the large data, they can tell what conclusion they can achieve. Cybersecurity protect the entire ecosystem. So notice that cloud computing sits at the center because many of Industry 4 technologies rely on cloud resources. As you can see here, we have a cloud. For example, smart factory can collect temperature data from thousands of sensors and store this data in the cloud, analyze them, and automatically predict equipment's failure before they happen. So these are the aspects of Industry 4. Going to the Industry 5, we can see that there are a lot of key enabling this technology of Industry 5. So while Industry 4 focuses on automation and efficiency, Industry 5 focuses on human-centered innovation. So this is asking how can machine, for example, replace people? Industry 5 focus about the cooperation between the human and the machines. So the point to this technology is that we can see AI. AI provides smarter decisions. We will see cobots, where robots working alongside the human. We can see, for example, we are moving towards 6th generation. We have digital twins, and digital twins, we can see kind of virtual copies of existing real system. So we can predict what's going in the real system based on these digital twins, which are virtual copies of actual real systems. There are kind of a blockchains where trust and transparency. We have also edge computing, which focus on computing on the edges rather than the server, and this would enhance the processing and many other things. So in modern hospitals, AI can analyze modern images, but the doctor still makes the final decision. This is a good example of Industry 5 where human and intelligent systems work together. I would like to say something before continue. It's very useful to look at the efforts conducted by your classmate related to the mind map of the cloud computing. It's very, very useful. You can see here cloud computer forensics, introduction to cloud computing, where the cloud computing concept, the industry from 4 to 5, and several definitions. This mind map is very useful, is very helpful. It will guide you to understand the whole chapter in a simple way and in a shorter time as well. I do recommend utilizing this mind map to facilitate the process of memorizing different aspects in this chapter. I know that this chapter contains of a lot of information. It's easy in terms of information, but I know that it's a lot. So considering this mind map would be very, very useful. Let's go back to the lecture. So what's cloud computing? Cloud computing provides convenient on-demand access. It enables ubiquitous. What is ubiquitous? Ubiquitous means everywhere, every time, present everywhere, found everywhere. And it also provides convenient on-demand network access to the shared pool of configurable computing resources. So according to NIST, cloud computer provides convenient on-demand access to shared computer resources, such as server, storage, applications, network. And instead of owning and managing everything yourselves, no, we will delegate everything to the cloud service provider, CSP. We will delegate everything to them, but we will just take care of the small things that we have. So there are several core definitions of cloud computing models, 5 essential characteristics. They are very, very important. They can come as, for example, MCQs, etc. And we will explain this in details in the upcoming slides. Okay, but in generic, according to NIST, we have kind of on-demand self-service, the availability, the priority access, resource pooling, rapid elasticity, and measured service. So what's on-demand self-service? On-demand self-service means that users can obtain resources whenever they need them without contacting the provider. So for example, if you would like to access your documents in Google Drive, no need to communicate with Google themselves. You can access your account easily without any interaction, without any communicating with the help desk of Google Drive. Broad network access, the second point, broad network access. What does broad network access? Broad network access, this means that a cloud service can be accessed from different devices through the internet. You can access the same Google Drive from your laptop, from phone, from tablet. Also, we have resource pooling. What's resource pooling? Resource pooling means that cloud providers share computing resources among many users. For example, millions of users store files in Google Drive using Google shared infrastructure. So shared infrastructure, shared servers, but each user has each user can access his files only. We have also rapid elasticity. Rapid elasticity, it is similar to like expanding expanding based on the demand. So rapid elasticity means that resources can quickly increase or decrease based on the demand. For example, during Eid, we know that users upload photos, videos, so Google can automatically allocate more storage and computing resources to handle this increased activity. You would like, or for example, we capture a lot of photos, so we have like Apple Drive where we can increase the capacity of the storage immediately. Measured services. What does measured services? Measured services means that resources usage is monitored and users pay based on what they consume. For example, Google track how much storage you use. So if you need more than the free storage limit, you need to pay only for the additional storage that you use. So these are the like characteristics that define the essential of the cloud computing, and it is also available here. So you can see, yeah, you can see them here. Now we will talk about this in details. It's explained in the slides and in the mind map. So let's go to the next definition. So next definition focuses on three areas. The first thing, we need to understand what are the essential characteristics that makes a service a cloud service. Then we will talk about service model, such as SaaS, PaaS, and IaaS, so which is infrastructure as a service. Then we will focus about the deployment models. We have four deployment models: public, private, hybrid, and as well as community. So for example, we know that Google Drive is a cloud service because it has cloud characteristics and follows service model, as well as it has different, like it deploys through cloud infrastructure. We will explain this in details in the upcoming slides. Let's go to the first one, resource pooling. What does resource pooling mean? Resource pooling means that cloud providers share computer resources among many customers. And instead of giving each customer a dedicated hardware, resources such as storage, memory, processing power are dynamically allocated based on the demand. So we'll not give each user a static hardware. No, those hardware will be dynamically allocated based on the need. So customers don't usually know the exact physical location of their data, but they receive the resources they do need. Think of a hotel, like if we would like to travel for a hotel, guests don't own the rooms, they simply use available rooms when needed. Similarly, cloud customers use shared computer resources without owning the underlying hardware or without even knowing the underlying hardware. So how is this related? So how is this related actually to forensics? This creates actually further challenge in cloud forensics because data from multiple customers may reside on actually same physical infrastructure. So we need to ensure segregation when we deal with users' data, because although one hardware can contain multiple users' data. Another one is elasticity. Elasticity, it is similar to scalability, okay? Similar, not exactly the same, but similar. Elasticity refers to the cloud's ability to automatically increase or decrease resources based on the demand. So if there is a very low demand, users will access those instances, but if there is high demand, we will access further services here, or further resources. So when demand increase, resources are added, and when demand decrease, as you can see here, resources are removed. This allows organizations to efficiently handle changing workload. So, for example, before Eid, an online shopping websites may experience a huge increase in visitors. This cloud can automatically allocate additional servers to handle the traffic and then reduce them once the event ends. Scalability means the systems can grow in generic, but elasticity, the system can grow, but automatically. Okay. Types of a cloud computing. Cloud services are commonly divided into three models: SaaS, PaaS, and IaaS. So what are these? So what is SaaS? What is PaaS? What is IaaS? So from the name, the name, we can see CS means software as a service. Here, platform as a service. Here, infrastructure as a service. So here we focus about applications, we focus about platform, we focus about infrastructure. Okay, but still you don't understand what's the difference maybe between platform and infrastructure. Still, we need to understand the differences further. Let's talk about them in details in the upcoming slides, okay? So the SaaS. SaaS means software as a service. It means that the cloud providers give you a complete application. It just give you a software. It just give you an application. It just give you an application. You don't install this application. You don't maintain this application. You don't program this application. You don't update anything. Simply use the software through the internet. The provider manage everything on your behalf. So including the servers or storage and updates. Example, can you give me example of SaaS? Yes. When you use, for example, Google Documents, when you use Google Word, when you use, for example, OneDrive, Word documents, when you use OneDrive, Excel, when you use, for example, Splunk Cloud, you use just an application. You don't care about the hardware, you don't care about the server, you don't even care about the operating system installed on the server. So SaaS saves costs such as licensing fee, installation costs, maintenance fees, and support fees. So in a simple way, SaaS means using a software. Okay, so after SaaS, what is PaaS, which is platform as a service? Platform as a service, I will give you more than software, okay? I will give you more than this. In this model, the cloud providers give users a ready environment to create, modify, and publish their application. User focus on developing the software. You are responsible for developing the software, while the cloud provider manage the hardware, the operating system, and other infrastructures component. In other words, users don't need to install, maintain hardware or software. They only focus on building the application. So imagine you are developing a website, and instead of buying a server, installing Windows or Linux, and configure everything yourself, the cloud providers give you a ready environment, and you simply develop and publish your websites in there. So PaaS allow developers to build and deploy application without managing the underlying infrastructure. So it is more than the SaaS, software as a service, such as Windows Azure, Google App Engine. Both of them are example of PaaS. Okay, what is an IaaS, which is infrastructure as a service? Infrastructure as a service, it is more than that. It provides virtual machine storage and networking. The customer manage the operating systems and application. So I will give you here an example. يعني the user can use the IT hardware and software just by buying the basics price for it. When, with the help of virtualization, the hosts can manage and create infrastructure resources at the cloud. Example of this is Amazon Web Service, AWS. So in the AWS, you can purchase or subscribe for several infrastructure as a service. So you manage the hardware, the software, the whole infrastructure. I'll give you another example. As a SOC team, you create several Windows and Linux virtual machines and Amazon Web Service to perform malware analysis and do the penetration testing. So you are not purchasing a software, you are not purchasing platform, you are purchasing the actual infrastructure, or you are subscribed to the actual infrastructure. So here is in a simple way, types of cloud computing. We have SaaS, PaaS, and IaaS. So in the SaaS, it is like you can access a service or an application. In the past, you access, for example, something, and you do the applications such as GitHub. Here you are, for example, OpenStack, AWS, etc. You are managing the container, the machine, the network, the storage, the hardware, everything in there. Okay, so simply, I know that many of you may be confused between them, but let me simplify it. IaaS is it's like being given an empty piece of land. You will build, or you have to build everything yourselves. You need to build the house, the rooms, the electricity, the furniture. Here, you are given just a land, but the PaaS, it's like you are giving the house with electricity, with water, and internet already installed, and you don't build the house itself. You just move and rearrange the furniture the way you want. In cloud computing, the provider manages the infrastructure, and you focus on building and deploying your applications. In the SaaS, the last one is like checking into an hotel. You don't care about the land, the arrangement, the furniture. You're just going to use the service. Everything is prepared for you. You simply use the room without building or managing anything. So a SaaS is like use an application, and PaaS is like building and deploying the application, but here building, managing the whole infrastructure. There are several deployment model or deployment methods: private, public, hybrid, and community. We will explain them in the upcoming slides. So here's the private cloud. What is private cloud? So the cloud infrastructure is provisioned for exclusive use by a single organization's computer, compromising multiple common service centers. What does that mean in the private? Private cloud is used only by one organization. The infrastructure is dedicated to that organizations, and no other organization would use the same hardware. So imagine our university builds its own cloud infrastructure, and only university staff and students can use it. So private means yours, your internal one, no one is going to use it. Community cloud. What is community cloud? Community cloud is like there is a cloud servers, but it can be accessed by multiple companies, by more than one company. So community cloud is shared by multiple organizations that have similar goals or requirements. They share the infrastructure and cost while following common policies. For example, several universities in Saudi Arabia share cloud platform for research project and academic collaboration. So people at Imam Abdurrahman University and King Saud University and others, they can use the same research, for example, shared or community cloud service. Okay, now we have public cloud. Public cloud is available to everyone, and I think this is the most common one when we are going to use our, for example, Google Drive, Dropbox, OneDrive. For personal use, this is public cloud, available to everyone who wants to use it. The cloud providers owns and manage the infrastructure. It's not the user. And this is the most common cloud model used today. For example, Google Drive, OneDrive, and many others. Those are examples of public. The last but not least deployment method is the hybrid cloud. It's a combination of public. Hybrid means a combination, okay? But combination of what? Of a public and a private. So as you can see here, for example, we have an enterprise, and this enterprise, it has a private as well as it has a public at the same time, a public and a private and another private one. So hybrid cloud combination, it combines both cloud environments, private and public. Organization keeps sensitive data on the private one. It keeps it on the private one, but it uses the public for less sensitive services. For example, here at the university, it can store the students' record in a private cloud, but it uses, as we are at this university, we still use OneDrive through the Windows, so we can use this public drive for email and public for collaboration. So what does hybrid? Hybrid means you are using public and the private. Like we have here 2 privates and 1 public. Now, after that, after we have talked about the deployment method, we will talk about the security or the risks in the cloud. So cloud security refers to the technologies, policies, and the procedures used to protect data and services in the cloud. The main challenge here is that your data is stored and managed by cloud providers rather than directly by you. And this imposes another security risks because you don't own the data by yourself, or you cannot manage it by yourself. So when a company stores customer data in Google Drive or OneDrive, the data belongs to the company, but the infrastructure is managed by the cloud provider. So in a single tenant and non-cloud environment, you generally know where the information is and how is being kept, but the cloud computer places business data into the hands of an outside provider, okay? Therefore, although it's your data in a cloud, you might have not direct control on it. Therefore, in the NCA Essential Cybersecurity Control, there is a specific domain related to the third party. Because we, like in many organizations that uses cloud services, we still need to manage the risks or reduces the risks that are imposed by using third parties. Okay, so here we can say that the following are the results of survey conducted with organizations that use cloud solutions. 91 concerns about the cloud security, 49 high risks of security breaches compared to the on the premise, because if it is on the premise, everything will be in your own, but if there are data that's outside your control, this would impose further security risks. Also, misconfigurations are the biggest security threats in the cloud. 80% experienced a cloud security incidents in the past 12 months. So cloud security introduces several challenges, including protecting confidential data, securing data shared by multiple customers, and controlling who can access the data. This challenge is keeping data. The challenge actually is to keep the data secure even though it is stored in a shared environment. Okay. Data security challenges in a cloud. So cloud computing introduces several challenges because organizations store sensitive information and infrastructure managed by third party. There is a need to protect these confidential data. And providing adequate security level for multiple tenants. security data mobility, protect data as it moves back and forth from the enterprise to a public cloud. We need to think about how can we protect data at rest, at transit, etc. So we need to think about different ways of protecting the data. They must be protected, or they must protect the confidential data, secure information as it moves between the organization and the cloud, and ensure that data belongs to different customers remain isolated even when resources are shared. Additional challenge, as we can see here, that include ensuring that deleted data is completely removed, meeting auditing and compliance requirement. So if we remove the data, is it actually removed from the cloud service provider or not? Auditing, reporting, and compliance concerns, because as I mentioned in the NCAACC, there's one major domain related to the third party. We have to comply to the regulation by the National Cybersecurity Authority. A new type of an insider who does not even work for your company, but may have control and visibility of your data. Who is this insider? Which is the CISP, the control service provider. The cloud service provider. A virtualized environment involves a new challenge in securing the data. Okay. Let's go back. Data security challenges in cloud. Data security in the cloud involves protecting information both when it is stored and when it's being transmitted. When data is in storage, which is we will call it data at rest, now organization will ensure that the data belongs to a different customers as properly separated in shared cloud environment, and that sensitive data is not replicated to unauthorized countries or region. We need to ensure this. But if the data in motion and you need to segregate, so here at rest we need to ensure that it is, for example, encrypted. But in motion we need to ensure that we are using the proper network protocol to protect the data during the transmission. For example, again, keep in your mind, CSP is a cloud service provider. So if the data is in motion, we need to ensure that the data is protected using protocols such as SSL, secure socket layer, and TLS, the transport layer security, for browser access or VPN, etc. So businesses always encrypt sensitive data in motion to the cloud. So here at rest, we need, it's good to encrypt it. In motion, we need to use a network protocol and to encrypt the data during the transmission to avoid any eavesdropping challenges or man-in-the-middle issues. One of the good, interesting aspects I would like to mention here is that one of the graduation project that was people or senior students are working this year called CipherWall. CipherWall, it says that, okay, we trust the cloud. As we use the cloud, we trust the cloud, but we need to ensure that the data at rest in the cloud is actually encrypted before it's stored in the cloud. And when we fetch the data, it will be decrypted. So it is kind of a way that it ensures the zero trust is that we don't trust the cloud. We add another layer of encryption for the data at rest. Now, in the CISP, which is the cloud service provider, it should support an IP subnet restrictions. What does that mean? This is one way to enhance the security. So it supports if the CIS support an IP subnet restrictions, allow organizations to control who can access their cloud resources based on the IP addresses. So instead of allowing access from anywhere in the world, the organization can limit access to trusted network only or trusted subnet only. So subnet segmentation would facilitate who is going to access the cloud. For example, here, we can see the company may allow access to this cloud from a subnet, let's say 172.16.2. 0. So only this subnet can access the cloud. The other subnet cannot access the cloud. So this device, the B, C, D, cannot access this specific cloud, let's say, cannot access this cloud. But any device connected from this subnet, they can access the cloud. So subnet access restriction policies to the so that enterprise can restrict end users access from known ranges of IP address. So subnetting would facilitate this thing. So university may allow access to specific cloud systems only from campus IP address. If someone tries to log in from outside the approved subnet, from outside this subnet, access will be denied even if the user provide valid credential, username or password. Okay, what kind of a cloud security threat? We might ask such a question in the exam. What are the cyber or the cloud security threats? And also you need to focus about the graphs or these figures. There are a lot of figures here. You need to focus about these figures and understand how these figures are explained very well. So traffic eavesdropping occurs when an attacker secretly listens to the data while it's being transmitted between the users and the cloud service. So here's the cloud consumers, and here's the cloud service. You are going to use a Google Cloud or Google Drive, but there is a person here, the attacker is going to listen to the traffic and copy the message. So traffic eavesdropping means listening to the traffic. So traffic eavesdropping occurs when the data is being transmitted or within a cloud is passively intercepted by a malicious service agent for illegitimate information gathering process. The point of traffic eavesdropping, we are just listening to the data. We're not doing anything. So what does this compromise from the CA triage? It doesn't compromise the confidentiality or integrity or availability. This would compromise the confidentiality. It does not compromise the integrity because the data is sent as it is. It does not compromise the availability because the data is sent. It compromises the confidentiality because the attacker listened to the traffic. Malicious intermediary. Okay, malicious intermediary is similar to the traffic eavesdropping. Plus, we're not just going to listen, we are going to listen and edit the message. So it compromised the confidentiality and it compromised the integrity. So the left side shows that the original message, as you can see here, but the attacker sets between the users and the cloud, change the message and send it forwarded to the destination. So the previous example, the eavesdropping, we are reading the message, but in the malicious intermediary, we are listening and modifying, which compromise the confidentiality and the integrity of the data. What about this one? The denial of service and distributed denial of service. So the denial of service, the goal of denial of service is actually to compromise the availability. So does it compromise the confidentiality? No. Does it compromise the integrity? No. It does compromise the availability to ensure that the targeted cloud service is not responsive to the valid users. So if we will see this one, here's the consumer, the attacker, sends lot of requests to the cloud computing, which makes the shared services unavailable to the legitimate user. So we are kind of compromising the availability. Again, to simplify it for you, just remember that the first threat is related to the CA triage, confidentiality, and the second one, confidentiality and integrity, and the third one is related to the availability. There are other threats we will explain in the upcoming slides, which is insufficient authorization. What is the insufficient authorization? This attacks occurs when an attacker gains permission that they should not have and access protected resources. So the insufficient authorizations attacks occur when access is granted to an attacker. So the attacker actually knows the credential of the actual user. Okay, so resulting in attacker getting access to the IT resources that normally protected. So the attacker here listens to the credential and he used the same credential to access the cloud resources. This is due to the weak authentication. So either weak password that can be prone to the, for example, let's say the brute force attack, etc., phishing, credential theft. So all of these, or even not using encryption during the data add transit. So all of this would result in insufficient authorization, and this would pose a threat to the cloud computing. Virtualization attack. This is very interesting. In the virtualization attack, cloud providers use virtual machine, as we mentioned this in the infrastructure as a service. So a virtualization attack occurs when the cloud consumer abuses their administrative access to attack the underlying infrastructure. So here is the trusted cloud consumer. He is trusted, but he is attacked at the same time, and he has subscribed, let's say, to a platform as a service, so he can not only access a server, but he also compromised the underlying infrastructure. The attacker is trusted, but he compromised the underlying infrastructure, and this, for example, to gain unauthorized access to other resources. So he attacked, let's say, virtual machine towards the actual host of this virtual machine. Okay. Overlapping trusted boundaries. What's overlapping trusted boundaries? Overlapping trusted boundaries means that customers often share the same infrastructure. This is already known. If one customer becomes malicious, they may attempt to attack other customers sharing the same environment. So let's explain this in this figure. Now, consumer A and consumer B both uses cloud resources within the same trusted environment. Consumer A first gain access legitimately. Consumer A access this legitimately, yeah, and also then attack the shared infrastructure. And after he attacked the shared infrastructure, he attacked the shared infrastructure and affect the consumer P resources as well. So here is both, they are legitimate, but this is a legitimate and attacker. He attacked the underlying infrastructure, and he could reach the virtualization or the other boundaries related to the cloud consumer B. So example, we can have two organizations shared same cloud infrastructure. A compromised customer exploit a vulnerability and impact another customer's virtual machine. So overlapping trust boundaries is like shared infrastructure creates shared risks. Okay, here's the security boundaries. Cloud Security Alliance. What is actually the Cloud Security Alliance? Cloud Security Alliance model. This is the stack model. Or like when I ask you, what is the Cloud Security Alliance? This is a Cloud Security Alliance. This is the stack or the model. It defines the boundary between each service model. We says that we have three service model. We have infrastructure as a service, platform as a service, security as a, software as a service. What are the boundaries? So the cloud providers become responsible for more security controls while the customer becomes responsible for the viewers. So as we move from the infrastructure as a service toward platform as a service, toward software as a service, the cloud provider himself become responsible for the security controls, and the customer becomes responsible for a viewer. Here, who is more responsible for the security and the security as a service? The more responsible is what is the CSP. Who is less responsible is the user. But here, and the infrastructure as a service, who is more responsible is the user. But least responsible is the CESP, which is the cloud security, cloud service. So let's explain this again. So in infrastructure as a service, here we can see that there are a lot of things. There's hardware, core connectivities, and APIs. All of this is the boundaries of the infrastructure as a service. The provider, the cloud provider, secure only the physical infrastructure. But as you can see here, so here is the IS, as you can see here. Here is this one, okay? But in the customer must secure what? He must secure the operating system. He must secure the application. He must secure everything. This is the IS. What if we, for example, use, for example, platform as a service? This is platform as a service. Platform as a service. And the platform as a service, the provider also manage the operating system, and he mentioned API hardware, but he's not responsible for the application. Customer is mainly responsible for the application. Okay, what if we, for example, have software as a service? Here is the boundary, software as a service. And the software as a service, nothing. The user is responsible for nothing. The end user is responsible for nothing. The provider manage everything, the hardware, the APIs, the integration, the application, everything. There is zero responsibility for the user. Okay, so here are the boundaries for each one. Okay, this is the IaaS, and this is the PaaS, and this is the SaaS. Here are some cloud security controls. So where's this here? We can see that here are all the security threats, the eavesdropping related to the integrity and the here the confidentiality, integrity, availability, and the other things. Also, here are some security challenges, the multi-tenant, the compliance, access control, the data, securing the data at a transit, etc. And what are the controls? There are several controls. What are these controls? Detective, preventive, deterrent controls, and corrective. What are the differences between them? So, first of all, is the detective. Detective means detection. Identify attack when they occur, such as monitoring systems and intrusion detection systems. They are just detecting, okay? React instantly and appropriately to any incident. It just detects, but it does not correct, okay? We have also preventive. Preventive is stop an attack before they happen. This is more powerful compared to the detective, because it strengthens the systems against any incidents or attacks by actually eliminating the vulnerability itself, eliminating the presence of the attack itself. We have also deterrent controls. Deterrent controls, what does that mean? It means سياسات للردع أو ضوابط الردع. We set several policies, several procedures, standards, guidelines, where discourage attacks from attempting an attack, such as security policies and warning banners. So not necessarily that there's an attack, but it's kind of a proactive process to prevent such thing. We have also corrective control. Corrective controls help recover after an attack, such as a backup and disaster recovery. So think of a house like we have lock. Lock is kind of preventive. We have security camera just to detect. We have spare key. This is a corrective if we lost the key. We have also warning sign. This is a deterrent. Okay. Cloud forensics. Cloud forensics is the process of actually collecting data, preserving data, analyzing digital evidence from cloud environment, and it helps investigators determine what happened during incidents such as breaches, unauthorized access, or inside threats. Unlike traditional forensics, the evidence may be distributed across cloud servers, several servers, user devices and provider logs. For example, we can see that an employee uploads confidential company's file to a personal computer, to a personal cloud drive account. Investigators examine cloud log to determine who accessed the files, when they were uploaded, and where they were shared. And there are a lot of cases related to the cloud forensics, such as cyber criminals, attacks to the cloud, fraud, data breaches, etc. The evidence in the cloud, as we can see here, evidence is the cloud. Cloud forensics, the location of the evidence actually affects what investigations can access and how easily they can collect it. Okay, so for example, if a company uses public and cloud service such as Google Drive, investigators may perform static acquisition of the employee's laptop to collect local artifacts. Okay, static acquisition, why we need to conduct a static acquisition here? On the device to access what data exists. And also we can conduct remote acquisition. So remote acquisition to collect files and logs stored in the cloud. So remote acquisition, by the way, means either to collect data remotely, either from a cloud or from distant server or from distant device. So access to cloud evidence may depend on the permission and the cloud provider. If the company owns private and cloud servers, this would be easy because investigators can still collect evidence from both the user's device and the cloud server. This is if the company owns the cloud server. But if the company does not own the cloud server, this poses another challenge because we have to contact the cloud service provider to facilitate the investigation. Yeah. Cloud forensics is often considered a subset of a network forensics. Why? Because cloud services depend on the network to store and access the data. It involves three dimensions: the organization, the legal, technical. What does the organization? Understanding where the data is stored and who manages the cloud service. The legal aspect cover or dealing with the service agreement. You know the service level agreement, SLA? Here's the legal aspect. SLA covers the service agreement and other jurisdiction matters. A technical focus about collecting, recovering, and analyzing the evidence from cloud environment. For example, investigators need to know where the data is stored, what laws apply, and how to collect evidence. One more important I would like to emphasize is that companies sometimes has its headquarters in London, let's say, or in Europe, but the cloud data may be stored in servers located in the United States. And this can happen for several reasons, such as lower the operational costs, better cloud infrastructure, improved performance. But another thing, from a forensics and legal perspective, this creates challenge because the data may be subject to laws and regulations on different countries rather than the country where the companies operate. Okay. Cloud forensics tools need several capabilities to investigate the cloud environments effectively. We have to have forensics data to collect data collection. We have also to have evidence. We have also to have elastic, static, and live acquisition. We need to consider how to expand the storage capabilities to consider live acquisition of the RAM, the static, and the elastic if there is expansion of the data, evidence segregation. We need to understand how the target organization's data, how it separates the target organization's data from other customers' data in shared cloud environment. Also, investigators in virtual environment. So we need to analyze virtual machines and virtual systems commonly used in a cloud infrastructure. So in short, cloud forensic tools must be able to collect cloud evidence, isolate relevant data, and investigate virtual environments. Again, when I mentioned the legal aspect here, I mentioned SLAs. What is SLA? Here is the SLA. Service level agreement. So, service level agreement. So if we go to the service level agreement, or you can search about service level agreement, it's a contract between company and the service provider. In our example, in our context, is an agreement between the cloud service provider and the customers that defines the expected level of service and responsibility of each party. What does it include? It's very important for the digital investigators to look at the SLA, because it shows what? It shows what restrictions apply to the customers by the CSP, at the availability of the cloud to the customer, for how long the data will be available after a breach has happened, or if there's, for example, we delete the data, or a level of support for a customer. Are you going to provide me a customer service 24 hours per 7 days? Response time for data transfer, throughput's limitation, contingency plan for incident response. How will you help me if there's an incident happen? So all of these are detailed and explained in the SLA. So digital investigator has to look at the SLA to facilitate the investigation. Also, the investigators should review the cloud service providers' policies, standards, and guidelines, these documents, because it explains how the cloud environments operate, where data may actually stored, and what procedures staff should follow. This information helps investigators decide where to collect evidence and understand any restrictions or applications related to the investigations. So it helps deciding where to collect data from, what are the standards to give guidelines to staff for operation, hardware, software, and many others. Where to access the data in the cloud? When an investigators need evidence stored in the cloud, they often require legal authorizations. We need to think about two aspects, the search warrant as well as subpoenas. So the search warrant gives investigator permission to access and seize specific evidence as a part of a criminal investigation. So we know previously search warrant actually means what are the device, including all its data. But in cloud, we don't mean the device, we mean the actual data, the actual content. Okay. So a search warrant gives investigators permission to access and seize specific evidence as part of a criminal investigation, but a subpoena, on the other hand, is used to request information or record from cloud providers or organizations without directly seizing a system. So if an investigators want to or want the content of a suspect cloud storage account, they may need a warrant, because I want the whole account. But if they only need account information, login record, subscriber details from the cloud provider, a subpoena may be sufficient. Subpoena means I just need a portion of data. But search warrant, it's kind of giving the account credential of this person. When evidence needs to be seized, warrants are used, which is normally issued by the law enforcement. When the only information is needed, subpoena are typically issued. So in a cloud, this means I need the whole account for this user. Here, I might need specific information from this account of this user. Mechanisms the government can use to get electronic information from a provider. Search warrant, subpoenas with prior notice to the subscriber or customers, court orders, and court orders with prior notice to the subscriber or customer. So government can obtain electronic information from cloud providers using different legal mechanisms. These are all different legal mechanisms, and the choice depends on the type of information requested. Again, if you want to know the whole accounts, you will go for the search word. But if you just need a specific information from this account, you would go to the subpoenas. Search warrant property to be seized usually describe data rather than physical hardware. Again, we are not going to act to collect the whole hardware or the whole server. Keep in mind, seizing hardware might be disruptive to the others. So surveying the data at the time of the day minimize disruptions. Typical challenges in the cloud forensics. There are several challenges. After discussing the legal challenges, let's go to the technical challenges of the cloud forensics. Cloud investigations are more complex than traditional investigation because evidence might be distributed among different actual locations. Investigators need skills in areas, including data recovery to recover evidence from different devices, network analysis to track cloud activities, database administrations as well, because we will explain this in the last slides of this lecture, to examine stored records and software security to understand how cloud applications operate. And in some cases, they may even deal with international issues. When data is stored in different countries. This is actually legal and technical at the same time. Okay, NIST also defined several challenges in conducting cloud forensics. These include understanding different cloud architecture, collecting evidence from cloud environments, analyzing cloud forensics data, dealing with anti-forensics techniques that we will explain in the upcoming slides, such as encryption or data hiding, coordinating with incident response team, because there are incident first responder at the CISP offered by the cloud service provider. Managing user roles and permissions, addressing legal issues, as well as standards and training to the investigators. So cloud forensics is a challenge because investigators must collect, analyze, and interpret evidence from very complex environment while dealing with the technical, legal, and organizational issues. Here is the infrastructure issue. Cloud vary in their architecture. If I ask you a question, for example, or true or false, two SASP are configured exactly the same way. This is very wrong way or very wrong statement because the cloud vary in architecture. So no two cloud service providers are configured in exactly the same way. They have different ways. Depending on the type of the cloud architecture, customers' data might be mixed, making it difficult to search through the data to determine what's relevant to the investigation and what is not. So identifying the data storage location, identifying the data storage location can be an issue, as well as because most SISPs keep these locations secret. They don't share, they don't tell where their servers are located. They keep it anonymous. In addition, differences in recording procedures or log keeping can make it difficult to determine data's origin and complicate the investigation's chain of evidence. Okay. Yes, this is very important aspect and analysis of a cloud forensics data. It's very, very important. If I ask you, how would you analyze the cloud forensics data? How would you conduct analysis on a cloud forensics data? If I give you a case and I will tell you, okay, can you tell me how would you conduct the analysis of the cloud forensics data? You would say it would be conducted through there are four different steps related to the analysis, not to the collection, but to the analysis. I have added this point to simplify the whole process. So the first one is data verification. The second point is data reconstruction. I will explain data verification. Data verification. So data verification means that verifying the data with other data in log record. The question is that why do we need to verify the data with other resources? Can we just depend on one resource? Simply because the data generated in a cloud is logged and saved in different resources and the places. So the main reason for doing this is due to the fact that all what is needed to access a cloud service is just an internet connection, and all cloud services can be then accessed at any time from different places. I mean, from personal computer, laptops, iPad, mobile, and many other devices. This indeed means there will be different logs, files generated in different devices, and that requires collecting and verifying logs from different devices to be the same in a more easy and use form. One of the sub-steps for data validation is verifying the validity of the data. This is a fact can be done by comparing the content from one device to a content from other device. So OneDrive, there will be some logs files created on the client sites, for example, client computer, laptop, mobile devices. Also, the same transaction, there will be some other logs created on the subs, for example, the sub server. So to make sure that the log file collected from either the clients or the servers are corrected and not tampered with, we have to check the log files on different resources. I have to check it from the client side, from the cloud server side. I have to check it from different devices to verify that this log is correct in all different devices and not corrupted. Okay, this is the data verification. Another one is the data reconstruction, and it's very important. What does data reconstruction? One way to analyze the data in the cloud is data reconstruction. This is necessary because evidence is often collected from multiple sources, and each source may record different details about the same evidence. So you collect part of the data here, part of the data there, part of the data from mobile, from the iPad, and then you provide the final image. Just to simplify data reconstruction, just think about it as a puzzle, okay? A puzzle. You might have one piece of information in the mobile, another piece of the information completed from laptop. And after that, you will have the full information. And this is how you do solve the puzzle. So for example, an activity may be logged on a user device, a cloud application, and the cloud provider service, but each log may contain different information or even use different file names. By combining and reconstructing data from these various sources, investigators can build a complete, accurate picture of what's exactly happened during an incident. So what's logged in source A might not be logged in source B, although they both logged in the same transaction. So I can take some information from here, but different information from here, and this will give us further information. So we need to reconstruct the data to have full picture. Also, another way of analyzing data, examining the MAC, which is the modified access and create data time. So when you compare the use time or the dates for the files, this would give further insights. Also, the metadata from affected devices or affected files should be examined as well to validate the file access. So again, there are 4 things: the data validation, data reconstruction, the MAC, as well as the metadata. Here, we will explain the data reconstruction, the second step. I will explain this in further details. I will explain this data reconstructions in details in the upcoming lecture. So here, what's data reconstruction? First of all, we need to outlining the goal and identifying the information resources. So I need to understand what is the goal of doing this reconstruction. What do I want to reach as a result? And then extract and combining data. I have multiple sources here from mobile, here from my iPad, here from my laptop. I need to extract and combine data. Then expect data collection and analysis, which is normalized and standardized data. What's normalized and standardized data? This one. Normalized and standardized. Normalized data means sometimes you will get data from, let's say, your mobile, and it is in a GMT format. But here, your iBAD is in Saudi zone format. So when you do that normalization, you need to ensure that the data collected from the first source, the GMT, and here from the Saudi zone, you need to convert them to have one standardized format to simplify reading the data. Because here may be 7, here may be, for example, let's say 7 GMT, and here 9 and Saudi time, or here 7 in London time, but here 9 in Saudi time. You think they are different, but they are actually, if you convert all of them to Saudi time, they are actually 9. So they are happening at the same time. So the normalization means make the values comparable. I can easily compare between them in a unified format. Standardization means make the format consistent. Means the process of converting data to a common format to enable users to process and analyze. So, we need to standardize and standardize as well as normalize. Understanding and validation, again, we need to do the validation from different resources, etc. Performing the analytics, check the whole data, read them very well, and then provide insights and guidance. So data reconstructions has those 3 steps, and it will happen through these. Here are the data, and here are insights where we keep those insights and the relation between those data together. Okay. So lastly, your job is providing insights and guidance on the obtained results, and you have to discuss them scientifically, and you have to justify the obtainable results based on the data. There are several ways of anti-forensics methods. So anti-forensics is destroying electronically stored information that may they may contain some evidence. So there are several ways of techniques where hackers can utilize anti-forensics methods, such as inserting malwares or program in other files, using encryption to obfuscate the malware program, using data hiding as well, that append malware to existing file, changing timestamps that can make it difficult to develop a timeline of a hacker's activities. All of these are anti-forensics techniques. Also, calculating the hash values of a file and comparing the results with known good files. Okay, it's a very good way to we know that sometimes the cyber criminals hide malware into some legitimate files, yet we already studied that the digital forensics investigator can use different techniques for validation, including known file filters and the national software reference library. We can compare an existing file with those things to understand what's legal, what's illegal, and we can separate a legal file and focus on illegal file and do the investigation to facilitate and to speed up the process of investigation. Now we'll talk about the incident first responder. When a cloud incident occurs, the cloud service provider usually has a trained incident response team. This is a fact, okay? Their job is to actually coordinate the evidence collection, ensure staff cooperation, follow management restrictions, and instructions, and preserve evidence properly. Since the investigators often cannot directly access cloud infrastructures, these responders exist in the cloud or offered by the cloud service provider, play a critical role in helping investigations. For example, if a company suspects unauthorized access to the cloud account, the cloud provider's response team may collect logs and preserve the evidence before it's overwritten. So, from your team, will the staff operate the staff and cooperative? The staff should should help should help or cooperate with us. Will the management issue the order? Did you need to brief staff about the operation security, train staff and evidence collection procedure? So the CISP should train their staff. They have to have like first responder staff, and they should train our employee to cooperate with them. Okay. So standards and the training. There should be a common standards that also follows. There is an effort to standardize a cloud architecture for operating procedures, testing, and validation. And the Cloud Security Alliance has developed research documentation for all SEFs and the staff to follow. So how can they deal with incidents? How can they train employee? What standards they should follow? Security measures they should consider, etc. It's available in this link. Okay. As for the training, cloud investigators should have an understanding of a cloud architecture. This would help them understand the underlying infrastructure. In addition to the basic digital and digital forensic skills, it's very good to look at these training courses related to the cloud. For example, Certified Cyber Forensics Professional, InfoSec Institute. They provide overview cloud forensics that you can access it through this link. SANS also provide cloud forensics with F-Response. Also, for law enforcement only, the National Institute of Justice Digital Forensics training, they have their own training. So there are several trainings that our digital forensics investigator they can have to facilitate the training. For the acquisition of the cloud, methods used to collect the evidence. There are several methods used to collect the evidence, and this is very important. Okay. So the acquisition methods depends on what happened during the incident. Network breach, if there is, for example, a network breach through CISP firewall, and the situation attacker enters the cloud environment through the network, investigators need to collect the firewall log, the service log, the server logs to determine the attacker's IP address, entry point, and action. If I have, for example, unauthorized database access in the situation, if there is any modification in the database, someone access or modifies data they should not access. If we have, for example, files or document investigation, okay, so investigations that require collection specific file and recovering, deleting artifact, the standard acquisition method should be used in this situation. I would like to highlight here further points is that here when there's a breach related to the network, here a breach related to the database itself, there's a modification in the database itself. But if a specific file, here the standards, because if we would like to focus about specific file. Okay, we have different ways of acquisition in the cloud. We have static acquisition, which is preferred way to collect digital evidence when a computer sees during investigation. We will consider static acquisition, yes, in the cloud. How? When the data resides in the edge, not in the server. Okay. So we will, for example, the mobile, the cloud, the mobile, the iPad, we will do the static acquisition. We can also perform the live acquisition. We will also perform the remote acquisition. That is more difficult because usually dealing with large volume of data, and for this we need the Saponia and the search warrant. Okay. Here, acquisition in the cloud, recovering deleted data from cloud storage might restrict it to the type of files that the CISP use. For example, if a CISP uses Microsoft NTFS RAID system, you can probably recover deleted data. But if they use different things such as Linux and Unix, you might face difficulties. Why? Recovering deleted data depends on the file systems and the storage architecture, as we mentioned this last semester. NTFS and NTFS file systems often retain metadata about the deleted data files in the structure such as the master file table, which can assist the recovery. But in Linux and Unix-based file systems and other distributed storage systems, they may reclaim or overwrite storage more aggressively, making deleted data recovered more difficult way. Okay. Here we will state that the snapshots are always helpful. With a cloud systems running in a virtual environment, snapshots can give very good way to understand what's happened before the incident occurred. So snapshots would play a significant role. If I ask you as a multiple choice question, to what extent the snapshot, for example, thinks that can help an investigator, snapshot would be a good choice because the snapshot help understanding what's happening before the incident happened, or during and after the incidents. Okay. Data sometimes might be encrypted, so you need to assistant to decrypted data. Many SIPs and third parties offer encryption services for class users as a security measure. Expect to find an encrypted file with the investigators, and this way you need assistance from the SIP to facilitate the decryption. So during the encryption, we need to consider the encryption to protect the data at rest, data at motion, and data in use. Data at rest means the data stored in the disks and the RAID servers in the cloud server. Data in motion when it was moved from the users and the servers, the cloud server. Data in use when it's processed in the RAM. So, encryption can occurs in all these several states. There are several vendors to provide encryption, including a 4-cloud link secure VSA from RSA, Apple Cloud Encryption, Secure Cloud, and Safeguard. All of these provide encryption for the cloud services. Now, when the SISP is the victim, okay, when the SISP is the victim, which is the cloud is the victim, investigators need to consider the following. We need to consider, do the investigators have the authority to use, the cloud staff and resources to conduct the investigations? Can I communicate with the cloud staff to help me with the investigation? Is detailed knowledge of the cloud topologies is required to understand everything? Are there any instructions on collecting the digital evidence? We need to review the SLA, service level provider. Is the data of interest to the investigation local or remote? If it is a remote location, can the SIS provide a forensic science connection to it or not? Also, cloud customers here. So if the SIS is the victim, we need to understand to what extent that cloud service can help the investigators. But if the customer is the victim, and let's say the cloud is, for example, has a malware that affects the victim or the customer themselves, cloud customers typically access cloud services in one of the two ways, right? They can access either through websites, or you can download an application. For example, OneDrive, I can have it as an application, or I can access from the Google Chrome by typing OneDrive. So here, if a cloud customer does not have the SISP applications installed, so we access it through a web browser, we can check the, we can find the cloud-related evidence in web browser cache file. But if the SISP application is installed, we need to consider something called prefetch. What is prefetch? Prefetch files are not a cloud artifact themselves. No, prefetch exists in any Windows, whether you have a cloud application or you don't. Okay, prefetch from the name, it means fetching. Okay, fetching. Windows creates them to speed up application startup. So when we access Windows prefetch, I would like to see if I can show you this one. Yeah, prefetch file in Windows. Yes, what are these? So if you go to the run and you type prefetch, you will see a lot of these. All these applications are running while you يعني during the startup. So we might see that OneDrive is one of the applications that runs on the startup. So I can say, okay, OneDrive is there. So also we can check this from the registry, prefetch parameters. It can has three variables. 0 means disabled, don't enable prefetch. But if it is 1 means that show me all the application, it will store all the applications during the startup. But 2 means only application related to the boots or only the boot prefetch enabling. Like what are the services that will be launched during the boots. 3 means the application and the boots prefetch. So this means show me all the services that will be launched during a startup and all the applications will be launched during the startup. So it focuses about the applications as well as the things related to the boots. Let's go back to the prefetch. It's very important and it contains several applications. One is create prefetch files to help applications to start faster. So they store information about the files, dynamic link libraries, the applications needs when it runs. From forensics perspective, prefetch files are useful because they can show that an application was executed on that system, and they also contains metadata such as the application's MAC, the modified, the access, and the created, and the number of times that the application has been run. For example, if we find that Google Drive or Dropbox prefetch file, we can confirm that the cloud applications was executed on the computer. Here is the prefetch as I showed you, and it has several numbers. 0 means disabled, 1 means application launch prefetch, 2 means boot prefetch, which means prefetch is used only to speed up the Windows startup process, but 3 means application launch as well as boot prefetch. The last few slides talk about several things, okay? We will talk now about, there are a few slides remaining that talks about Dropbox, Google Drive, and OneDrive. Where can we find the data in there? So if we go to that, to this one, we already covered the analysis, the data reconstructions, the anti-forensics, the incident event responder, also here I mentioned regarding the rule management, the personal identifiable information. Personal identifiable information are very useful. Personal identifiable information, for example, your date of birth, your family name, your ID, etc. Those called personal identifiable information. Here, investigation where the cloud is the victim and the customer is the victim. We compare between them, understanding the prefetch file, examining. Yes. The last few slides talking about storage cloud data. Where can we find the cloud data if it is if we are using Dropbox or Google Drive or OneDrive? Here we will talk about Dropbox. Here we will talk about Google Drive, Dropbox, and Google Drive. So, yeah. So there are these are the most commonly used cloud storage services, Dropbox, Google Drive, and OneDrive. They allow users to store, synchronize, and share files across multiple devices. These devices or these services offer free storage to the user. So, for example, it offers, this is the free storage up to this for Google Drive and OneDrive. And I think this varies from year to year, depends on the organization. We can check, for example, here, I can type Google Drive available storage. Yeah, they can offer up to 15 gigabytes for free, but then we will see the subscription. And we can see all the prices here. So, yeah. So 15 free till 100 till 200, etc. So here's just tell you the free from 2 till 15, 2 for Dropbox, 15 for Google Drive, and OneDrive. And the data will be stored where? If I have this application, it will be stored in the registries, it will be stored in the prefetch, in the web browser, and many other things. Okay, now we will explore the Dropbox. Dropbox is the first one. Offer third-party applications such as email, chat, Cisco WebEx, and other collaborative tools. We can find all the data related to the Dropbox and see then the users, then the username, if your name is Nana, Maha, whoever, what will be written here, the Dropbox. Since 2012, Dropbox has used base 64. What's 64? 64 encoding. So you need, as an investigator, you need to decode data during the analysis to see the data. Okay, this is related to the Dropbox. What about the Google Drive? The Google Drive, we will see the data stored in different places. The first place, which is this one, is the Google Drive application itself. So we will see the Google Drive application itself stored here in the programs. Because this is a drive, it will be stored in the programs. But we also will see the user profile. The user profile here. So here in this path, we will say the user profile, which stores user-specific information such as settings, logs, accounts, and details, and synchronization activities. So the first folder is just like the Google Drive exists on the computer or not, but this one, how the user used Google Drive, all the profile will be stored here. Okay, there are several important database stored in the Google Drive, and they provide information about the Google Drive. First of all is syncconfig.database, snapshot.database, and synclog.log. So what's the first one? The first one, synclog.database, contains configuration information such as Google Drive version, upgrade information, and local synchronization, which is the root path. Okay, where's the synchronization root path? The second one, the snapshot database, it contains metadata about the synchronization file. What are the URL path name, the modified and the created dates, the timestamps, etc. So it is a snapshot of everything. The synclog.log, it's a log file that logs every details that users does with the application, such as deleted drives file. If I delete any data on the drive, the log of the deleted data on the drive will be stored in the synclog.log. Okay, so this one about the settings, this one about the file metadata, this one about the user activities and history. I think we can see them here. Here's snapshot database. There are a lot of databases, sync, config, global database, etc. But here are the important things related to the forensics. Okay, so we finished from Dropbox, we finished from Google Drive, we will talk about OneDrive. OneDrive previously was called actually SkyDrive. It's available with Windows 8 and similar to Dropbox and Google Drive, and offers subscription services for Microsoft software. Now it's called OneDrive. OneDrive is actually stores user profile and user's account path and log files and synchronization file kept in various places depending on Windows version. And the data will be stored actually here. So here actually contains the log file created by OneDrive that records synchronization activities, the error, account actions, and file transfer events. So it's very important. So those things is useful. It might come as an MCQs to understand how this, what are or lists the important files related to the Google Drive, etc. I wish after that you go to this one, because this simplifies everything. We just cover the cloud computing, the meaning of it, what are potential evidence in the clouds, what are the security threats, what are the technical and legal challenges, what are the important analysis, what are the encryption, what are the how can we conduct the acquisition, and this like also the it's very important to understand the prefetch. Also, here in a simple way, how can we conduct an investigation in Dropbox as well as in Google Drive, as well as in OneDrive. Thank you so much, and I hope everything is clear. I know that the lecture contains a lot of information. It's not that it's simple to understand. It just need to memorize everything and simplify everything. If you understand this would be very useful to understand the whole chapter. I wish all the best for you. Thank you so much.